Hi everyone, I'm Isaac
And I'm Claire.
and we're here in the beautiful city of Bath to record the next installment of Welcome series, which is...
Extreme Fabric Connect, a very hot topic at the moment, so I am looking forward to this one.
Do you know what it is?
No, not yet, but this is why we are here. To learn about some introductory technical training. Fair to say, we're not getting too deep in this one.
No, it's going to be 4 episodes and really it's just designed to unpack this topic. Fabric Connect, what a name to choose for a product, for a networking company.
It could mean anything.
Exactly.
So we're going to find out what it is over these episodes. Make sure you guys keep an eye out for any QR codes or URLs that we're picking up. They're there to help you, and mainly it's to connect to our Extreme Training LinkedIn. So please follow us on there because there will be constant updates with what's going on with this product and any training that can help you.
Yeah, and the other thing is if you need to email us to ask us questions or whatever, you can use learn@extremenetworks.com. That's how you'll get to Claire or somebody that will respond to that.
Absolutely.
Should we hit the studio?
Yeah, let's go.
When I started working at Extreme Networks, I often heard people talking about fabric. And people then would say, oh, Extreme Fabric is fantastic. Like, okay, is that like a type of a t-shirt that you have that's made with Extreme Fabric? Let's put it like this. Networking engineers, we're not the best at naming things. So what is fabric? What is Fabric Connect? Well, I went out in Cambridge and I went to a fabric store to find out if I could buy some Extreme Fabric. Well, here we are on our way in to go and see if we can find some store or location where we can buy some Extreme Fabric. Not having much success, to be honest, walking down these aisles. I see bed sheets, I see linen, but I'm really looking for fabric. Yeah, not having a lot of luck. Oh, there we go. Fabric by the meter. That must be it. Fabric by the meter. Let's see. Oh, well, okay, here we go. We have some rolls of fabric over here. There we go. What else do we have? Ah, there we go. Fabric. That's what I'm looking for. Fabric Connect. I wonder if they got something called Fabric Connect. They don't even have purple fabric. Oh, well, at least they've got fabric glue. That's probably part of the tools. Oh, and fabric stiffener. Definitely, that's got to be a tool for fabric. Oh, more tools. Fabric weights. Not quite a networking technology, right? It's kind of not found in a store that sells fabric. So if it isn't physical fabric, what is fabric or Fabric Connect, right? Fabric Connect. Most times when you don't know the meaning of a word, you'd go to the Oxford Dictionary. But I'm from Cambridge. And we also have a dictionary, the Cambridge Dictionary. Let's see what the Cambridge Dictionary says. The structure of something, the parts of something that hold it together and make it what it is. I think that's a really fantastic explanation of the word fabric. Fabric networks get their name from the diagram of their component connectivity, which looks like and resembles a piece of fabric. Imagine that we're going to take a trip from Cambridge to Paris. We would use a road network that would take us from location A to location B. For many years, going from Cambridge to Paris would have involved other forms of transport other than a car. I would probably have had to drive all the way down to the coast and then they put the car onto a barge and on there travel across the English Channel get to France, get off the barge, and then drive all the way to Paris. Could I get there? Yes. So today, it could probably take me, if I left early in the morning, I don't know, maybe 8-9 hours, and I could be in Paris. Or I could take the car and put it on the Eurostar and go under the sea and come out on the other side, still on the train, and end up in Paris. So today I have a lot of ways that I could get to Paris. What if I took a flight? If I drove to the airport and then got out and had booked a flight to Paris, I'd simply get on a plane, and in maybe 45 minutes, maybe less than that, I would be in Paris. Imagine that. There's only one stop. I leave from the UK and I arrive in Paris. One stop. If I was taking a car, I'd need to drive. I'd need to know the codes of the road in the UK. If you come from the US or from Europe and you come to the UK and you need to drive, you realize that we drive on the right side of the road, which is the left side of the road, which is right. Yes? You would need to understand that we use a lot of roundabouts. Everywhere in the UK you have roundabouts, and it's confusing, especially when you have lots of exits and entries into a roundabout. So you would need to understand that. You would need to understand the laws of the road. What speed can you go on a motorway? What speed can you go on a town road? What speed could you go on a dirt road? So you'd need to know all of that. And when you got to the Eurostar or the barge, well, there would be different protocols. You would need to stop your car, put it in gear, pull up the handbrake. When you get to the other side to France, you'd need to show that you have an emergency triangle in the boot of your car. There are different protocols. If I got to France, well, what would I need? Well, I then have to drive on the wrong side of the road. None of that would happen if I flew. All I needed to be concerned about was getting to the airport. The plane would take me the rest of the way. In a sense, that's what Fabric Connect does. You get into one side of the network and you exit on the other side in a beautiful, simple, clean way. Does the other road network still get you to France, get you to Paris? Of course, yes. But flight changed the game. That's what I'm going to show in these next episodes of Fabric Connect. How do you build a traditional network? Well, you take a switch, you plug in Ethernet cables, you take those cables to computers, voila, you have a switch, right? Easy peasy. Well, maybe if you have just one switch on your network, it's easy. What if you have 500 people in a building with 8 floors, 2 people, 2 offices on floor 1 and 2, maybe floor 15? Is it as easy? It starts to become a little bit more complicated. What if you have a university? What if you're building a university, a network for a university, where you have distributed buildings all on one large site, and you have maybe 5,000 students on the campus, and you need to provide network accessibility for all of these people, no matter which building they are, no matter where they move to, whether they're in a canteen or not, or in a lab, they have access to the content, to their files, to the research that they need. Is it as simple? We try and make our technology really simple. And if you were to compare our technology to how it used to be 5 years ago, or 10, 15 years ago, then you could say, oh, today it's so much easier. It's so much simpler. But that's because we've tried to build simplicity into all of this technology. But what if you take an organization that is distributed throughout not just a campus area, but distributed throughout an entire country? The UK is an island, right? In reality, it's not that big when you compare it to the USA or China, for example. It's quite small, but we can get very complex networks in that environment. How much more if you have an organization that is an international organization that trades in countries all over the world, that has staff and people and offices all over the world? Is it still simple? No. it is complex. And that is the nature of traditional networks. Do they work? Yes, of course they work. Do they get you from Cambridge to Paris? Of course they do. Can they get you there reliably? Of course they can. But they have characteristics that we live with because that's just the way that they've always been done. For example, if you have mission critical networks, you're never just going to have one switch being the mission critical one. You're going to layer switches. You're going to have at least two, and you're going to connect them up so that if one fails, the next one will be able to carry the load. And that would mean things like having multiple power supplies on each one of those switches. Redundancy, that is important. When building mission critical networks, redundancy is so important. If you're an Amazon, if you're a Microsoft, to millions and millions of customers, you really can't afford to have a switch fail over and knock off, millions of users for a day or two or three from getting access to the content because of a hardware failure. So you would make redundant connections between them. And that leads to an interesting problem, which is a loop, okay? A spanning tree loop. In another series that I did for Extreme Academy, we spoke about this, how loops are an absolute crippling mechanism for a network. If your network develops a loop, it can literally bring a network to a complete standstill. So you build these traditional networks, you put redundancy in, but the fact of you putting redundancy means you open yourself up to having spanning tree loop. So what do you do to prevent that? Well, you use spanning tree protocols to detect a loop on your network. And if it detects a loop, what does it do? Well, it's going to block that port on that switch. And it's going to say to that switch, you see that port number 18 over there? I want you to disable that because that is causing a loop to happen and bringing the network to an absolute standstill. So when we talk about a small network with 2, 3, 5 switches, that's not a lot. But we have customers with 1,000 switches or 2,000 switches in their networks. Suddenly becomes a lot. So the IEEE, they come to the rescue and give us what? Well, they give us 802.1 AQ, Alpha Quebec. That is a fantastic protocol. And another common term for that is shortest path bridging. Remember that. Shortest path bridging, SPB. Enabled technologies like Fabric Connect to change the traditional approach to building networks. Because all of a sudden, Ethernet in and of itself has no path, doesn't quite understand paths. And what we need to do is we need to layer protocols on top of protocols, on top of protocols, to be able to create networks that are intelligent and flow and carry out data smartly from location A to location B. Shortest path bridging is an IEEE attempt to make that much more intelligent. And that's where Fabric Connect sits on top of. Why do we need Fabric Connect? And I'm now going to go through some of the points where people who are network administrators, people who manage networks, and I'm talking about really big networks, the stuff that they do on a day-to-day basis, this is going to be one of those areas that I'm going to show you as Fabric Connect. When you deploy that in a network, these are the areas, and I'll list them as we go through, that people who manage networks look at it, understand it, and then they say, oh, that makes this so simple. I can't believe I've been doing it this way all the time. I can't believe I've been driving to Paris from Cambridge every 2 weeks when I could have just taken a plane. Follow along with me as we go through these points. Stay grounded, stay watching. You're going to learn a lot about Fabric Connect. So the first point that I want to address as to why you would want to use Fabric Connect is complexity. Not that it's complex, quite the opposite. It relieves complexity. In a traditional network, like I mentioned, you have multiple protocols that you will stack on top of each other to be able to achieve a scalable, large, reliable network. And that's perfectly okay. No problem with that at all. But that means that there is complexity by its very nature. If you have multiple protocols and they are interdependent, so the top protocols are dependent on the bottom ones. If one of those bottom protocols fails, the entire stack fails. So does it work? Yes, of course it works, but you have risks. Imagine if you have to have people in your organization, in your company, that have skills on MPLS, ISIS, on all these different protocols because they're fundamental to the way you build these networks. That becomes a skills tax. People with those types of skills cost a lot of money. Complexity in its very essence equals expensive. The second point is agility. Businesses today want to be agile. They need to respond to changes on the fly. If you're an agile business, your network needs to be as agile as you are. Otherwise, your business is held back. Third topic we're going to talk about is security. We do have a lot of people at Extreme Networks who do know a lot about security. Go and watch this video by Ed Kohler. He's one of our technical fellows, where he talks about the security aspects of Fabric Connect. And I think that he does this topic much more justice than what I can do. The fourth point is flexibility, the ability to reorient it, to go from one type of topology to another type of topology, to scale it from 50 users to 50,000 users, from 5 offices to 500 offices. Flexibility on a network is something so fundamentally important to the way a network engineer works. Point 5 is show me the money. Having a system that is flexible, that is agile, that is secure, having all of those things and being able to have it run by a very small team across a massive network is an incredible advantage for a network administrator, is an incredible advantage for a company. So why spend all the money on running traditional but older technology networks when you can go with something that gives you all of that at a much lower cost? I came across a really interesting article about one of the most prestigious hospitals in North America. Around about 2001, the IT department was ranked 16th out of 500 organizations. 2 months later, they had an absolute nightmare on their network, which was built the traditional way that I spoke about earlier. I didn't know this, and this is why I found the article so interesting, that if you take a switch and you plug another switch into it, and then you plug another one into that one, and then another one into that one, and then another one, you can only go 7 layers deep. Spanning tree protocol, that protocol used to prevent loops from happening, will only save you up to 7 layers down. After that, you're on your own. Guess what happened to this medical institution? Somebody added a switch right at the edge of the network, made 8 layers. They had an absolute nightmare of a couple of days over a weekend. Got to the point where doctors were looking at patient records and writing in by hand. It could happen to anybody. How do you control? How do you know whether you have 8 switches connected or 7 switches connected to each other? Today, it might work perfectly, but somebody does something and all hell breaks loose. If you had a network using shortest path bridging, that would definitely not happen. It simply would not happen. The article is fantastic. It is such interesting reading, and I really encourage you,
have a read. It will just expand on the dangers of traditional networking and how shortest path bridging could resolve that. Here's the QR code. Follow it. Really easy to read. I'm going to give you a sentence that you can use when somebody says to you, "What is Fabric Connect?" Here it is. Fabric Connect is a technology that takes a modern approach to building computer networks using open standards. Thanks so much for watching. I hope you enjoyed that intro into Fabric Connect. I'm doing episode 2, 3, and 4, so feel free to watch them. Please come and watch them and learn more about Fabric Connect. Don't forget to follow us on LinkedIn training. The QR code for that is up here. We do a lot of stuff on LinkedIn, so follow us, get more news, see little snippets, and get more information if you want to learn more about Fabric Connect.